the same, like you got the same kind of thing that I'm expecting, then feel free to join in, okay? And feel free to talk to me so I'm not just talking to myself. Okay, so number 11, it says, what are the properties of exponents? So let me zoom in quite a bit more. So properties of exponents. Okay, butchered that spelling, but oh well. Okay, so properties of exponents. What did you guys find as far as properties of exponents? What are they? So what are they? Okay, so like if you're talking about like if I add x squared plus like another x squared or x to the third. Yeah, that one. Um, no. Okay. Yeah. Okay. I was wondering what that would. Because we actually like if you could add those, then we wouldn't be able to have polynomials with multiple terms. So I think what you're actually thinking is the product property. So the product property says if I have like x times a or x to the a power times x to the b power, and I multiply them, what does that mean I can do to their powers? Exactly. So when you multiply them, you can add the powers. It's x to the a plus b. And so if I show you right quick, 2 to the second times 2 to the fourth. Can you guys tell me what 2 to the second power is? That's 4. What's 2 to the fourth power? 2, 4, 8, 16? 16? Yeah, what's 4 times 16? Do y'all know how to do 4 times 16 really quickly in your head? Yeah, but if you don't know it ahead, you can say, what's 4 times 10? What's that? 40. And what's 4 times 6? 24. 40 plus 24 is 64, right? So, do y'all know that 64, 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32, and times another 2 is 64. That right there is 2 to the sixth power. So 2 to the second times 2 to the fourth, of course I go right through it, is the same thing as 2 to the 2 plus 4, or 2 to the sixth. Cool? That was me just exploring it with you. As far as an example goes, if you wanted to say 3 to the fifth times 3 to the third, what's that going to be? 3 to the what? 3 to the eighth. Good. What's another property? Are you talking about like raising it to the zero power? Yeah, okay, so what is a number raised to the zero power? Any base. Right, so if you have, good, if you have any base raised to the zero power, it is 1, except 0. 0 to the 0 is indeterminate. We don't know what that is. Okay? As far as like another one of those where it's got like a name, we've got the quotient property. No what? No, you need to know how to use them. Okay? So quotient property, that's division. So write down x to the a divided by x to the b, if you haven't done this yet. Do you guys remember what to do here? Yeah, it's subtraction, and then let's explore that numerically. If I asked you to divide 27 by 3, what would you say? It is 9. What is 27 the same thing as 3 what? 3 cubed. 3 is the same thing as 3 to the first. What is 3 minus 1? 3 to the second power, and that is 9. Okay? So this right here, for the rule, I would write x to the a minus b. Perfect. Okay, and then if I had now I do want to ask you, what if what if I gave you the problem x to the 10th divided by x to the third? What would that be? X to the what? X to the 7th? Well, what if I said x to the third divided by x to the 10th? Okay, two different ways to do this, exactly. Go ahead, what were you going to say, Jordan? Perfect. Those are the two expressions that we can have. You could say x to the negative seventh because 3 minus 10, but that's exactly right. If you have a negative power, that's the same thing as just saying 1 over x to the seventh. And an easy way to do that, although I wish I hadn't picked 10, is 1, 2, 3 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, something divided by itself is 1. 3 of those go away. I'm left with 1 divided by x to the seventh. Cool? Okay, just so we're clear that those are the same. All right, there's another one, the power property. What if I have x to the a to the b? What do I do with their powers now? I multiply them. Good. So that's going to be x to the a times b. And an example, a numerical example of that would be like 2 cubed squared, right? What is 2 cubed? 2 times 2 times 2? 2 times 2 is 4, and times another 2 is 8. So what's 8 squared? 64, right? But that's the same thing as saying 2 to the 3 times 2, which is 2 to the 6, and 2 to the 6 is 64. Okay? So I would expect you to be able to tell me that if I asked you what's x squared to the 5th power, you would tell me what? X to the 10th. Good. Okay. Properties of exponents. Good. Let's talk about 12. Did anyone else run across a different property? Because we did the power of 0 is equal to 1. Did anyone ever run across something else that you thought was something that you might put down? Okay. Yeah, okay, so you and was that you, Jordan? I wasn't looking. Okay. So you and Jordan were saying the exact same thing about the rational power, right? And since that's in number 12, we'll go ahead and talk about that now. What does it mean to have a negative power? So guys, if I told you we're dealing with the function x to the negative second power, what's another way to write that? 1 over. Good, 1 over x squared. And so what if I asked you to rewrite x to the negative second divided by y to the negative fifth? So there's two different ways to do this. There's one which is the more difficult way. I could rewrite each of them as 1 over and 1 over. And then what do you do when you divide by a fraction? When you divide one fraction by another? Did we talk about this together? Oh, okay, I've talked about it with some of my classes. So this is going to be really important because, exactly, what do I multiply by the reciprocal? Just the denominator, just the numerator, or numerator and denominator? Okay, so I'm going to take a second. I have a lot of people that know that if they got a problem that says 2/3 divided by 1/8, that means 2/3 times 8 over 1, but they don't know why. Do y'all know why? Justin, you with me, or you? Okay. You don't have to be with me, but maybe not our watch. Okay, so 2/3 divided by 1/8 equals 2/3 times 8 over 1. Yeah? The reason why is because when you divide a fraction by another fraction, okay, it's moving everywhere. If you actually multiply by the reciprocal of the denominator in both the numerator and denominator, which I can do because something divided by itself is what? 1. These two simplify out, and I'm left with y to the 5th times 1 divided by x squared times 1. So this becomes this. So what's the shortcut? If it's in the numerator with a negative power, where does it belong? In the denominator. If it's in the denominator with a negative power, where does it belong? In the numerator, and there you go. Okay? So if you wanted to write x to the negative second over y to the negative fifth equals, and then y to the positive fifth divided by x squared. That would be a good example. Okay. The other part of 12 was having a rational power. Okay. So let's talk about rational powers for a second. Can we all agree that the cubed root of x cubed is x? Yeah? Well, here's the thing. The reason why that works out is because the cubed root is actually a power. It's the same thing as raising x, and those of you that have already answered this question, what do you think? Good. It's x to the 1/3. And then the power property tells me that if I raise something to a power and then raise it to another power, what do I do with those two powers? I multiply them. What is 1/3 times 3? X to the 1/3 times 3. 1/3 times 3 is 1. And so you can see that's why those operations simplify each other out. It's because one's just the reciprocal of the other. Yeah? So, guys, what if I asked you, what is x to the 1/5 power? What would you tell me what that means? What am I finding? The fifth root of x. So a rational power is another way to write roots of expressions. You can say of expressions, of values, or just roots and call it good. So what if it was x to the 4/3? What would that be? Good, Cody, and good, Brandon. So now you said the cubed root of x to the 4th. Is the 4th power inside or outside? Okay, inside. I'm hearing inside. Are we sure? Do we know? Okay. Well, let me play around with that for a second then. I want to think about x or 8 to the 2/3. So there's two different ways to write this: the cubed root of 8 squared, or the cubed root of 8 squared. There's one method I prefer to always do. Go ahead. Mm-hmm. What's the cubed root of 8 though? Let's go ahead and do this one, guys. What is the cubed root of 8 is 2, right? Do y'all remember that? Are y'all know 8 is 2 cubed? 2 times 2 times 2. So the cubed root of 8 is 2. Yes? Okay. So this right here is 2 squared. What's 2 squared? 4. So this answer is 4. But what's this? What's 8 squared? So it's got the cubed root of 64. Well, guess what? 64 is what? 4 cubed. The answer is 4. Don't I get the same answer? Okay. So it can be on the interior or the exterior, so I would write down both. Okay. I am going to stop the video for a second, but not for, like, I'm not going to stop presenting, but I'm just going to stop the video for a second and then start up a new one in just a minute.